In this video, we are going to see about round robin scheduling algorithm. This round robin scheduling algorithm, we don't have any preemptive or non-preemptive type. Okay. See here, we are having 5 different processes. All these processes has the arrival time as 0. We are considering like that. That is, all these 5 processes are arrived at the starting itself, at the 0th millisecond itself. Likewise, we are considering, and in this problem, the burst time will be only given, not the arrival time, because we will be considering the arrival time for all the processes 0 millisecond. Okay. Then, how this round robin scheduling will execute the process means, here we will be having a time slice or time quantum. That will be a value of 3 millisecond or 4 millisecond. It will be like that. That is, for every time slice only, each and every process will be executing once. After that, after completing the particular time slice period, all the process will be repeating its execution again. Okay. See, here we will see then example problem. Okay. Here the time slice is given as 3 millisecond. So each process will be executing for 3 millisecond only. After, if it has remaining execution time, after the completion of all the process within the time slice period only, the remaining process will be executed. Okay. So first we are having process P1. So process P1 has burst time 5 and it has time slice 3 millisecond. So this process P1 will be executed up to 3 millisecond because all the process will be executing only for the time slice. So remaining will be having 2 millisecond to be executed. So keep it in mind. At the next time slice will be executing the process. Next, process P2. This process P2 has a burst time 3 millisecond only and the time slice is also 3 millisecond. So we are having its execution here 3 plus 6. So 3 plus 3 it is 6. Okay. Next process is P3. So P3 also we can execute only 3 millisecond because the time slice is 3 millisecond. That is 6 plus 3 9. Here remaining we have to execute 7 millisecond for process P3. And then for process P4 we can execute only up to 3 millisecond. That is 9 plus 3 12. So remaining 4 millisecond we have to execute. Next for process P5 here we are having 2 millisecond. But the time slice is 3 millisecond. Then it will get completed before the time slice. So P5 will be executed up to 14th millisecond only. Okay, next. Now we will have these 3 millisecond time slice again for each and every process to execute the remaining execution time. Okay. See, for P2 we are having remaining 2. So for P1 we are having remaining 2. So this P1 can execute up to 3 millisecond. But here we are having only the remaining execution time as 2. So only up to this 2 millisecond, that is up to 16 only will be executed. Okay. So this P1 has completed its execution. Already we have completed the execution of P2. Next we will be seeing P3. Since here we are having the time slice 3, this P3 will be executed up for 3 millisecond only. That is 16 plus 3 up to 19th millisecond. So the remaining is 4 millisecond. Okay. Next, we have to execute P4. This the time slice is 3 millisecond. So from 19 to 22 only this process P4 will be executed. So here the remaining time will be 1 millisecond to be executed. Then the process P5 has only 2 millisecond to be executed. But this process P2 has completed its execution here itself. Process P5 has completed its execution here itself. So we no need to complete again the execution of process P5. So now we can see what are the remaining process to be completed. Okay. If you see like that means here we are having process P3. This process P3 has 4 milliseconds to be executed, but the time slice is 3. So up to 3 milliseconds only it will be executed. Okay. So remaining will be having 1 millisecond to be executed. Next we are having process P4. This for executing 1 millisecond. So this 1 millisecond will be executed. Okay. Next, last we are having remaining 1 millisecond in P3. Then this P3 for 1 millisecond will be executed. That is up to 27th millisecond. Okay. Next here we can compute the completion time. To see the completion time for process P1 means we have to see from backwards. Here we can see the completion time for process P1 is 16. For P2 the completion time is 6. For process P3 the completion time is 27. For process P4 the completion time is 26. For process P5 the completion time is 14. Next we can calculate the turnaround time. Here we are considering the arrival time as 0 for all the process. That is all the process arrived at 0th millisecond. So by using the formula if we see means turnaround time will be equal to completion time minus arrival time. Here it is 0. Then it will be equal to turnaround time. So if you want you can write it as same as completion time. Okay. Next, to calculate the waiting time. Waiting time means the formula. Using the formula we can calculate. That is waiting time is equal to turnaround time minus burst time. So here we are having the turnaround time. By subtracting the burst time, we can compute the waiting time for all these. Simply I am subtracting all those values I am writing here. Okay. This is how we will be calculating all the values for round robin scheduling algorithm.